Is it good? Okay. Okay, so I'm Jacob Hicks, and my topic this year in ISM is biomedical engineering. But I've had a different view on that lately, and it's not so much biomedical engineering anymore as it is mechanical. Okay, a quick bit about me is I'll be attending Texas A&M in the fall of 2016. I'm going to be studying biomedical, mechanical, or petroleum engineering. As I said, I'll probably be studying mechanical and not biomedical. It's too niche-y. I'll get into that later, though. I'm a member of the varsity golf team, and I'm the president of the FHS Orchestra. I'm also a member of NHS and Climate Committee, and I'm a member of the YMSL Frisco chapter with other beautiful people like Travis. I'm a guitarist and performing musician of almost 12 years. I play viola, too. My mission statement this year in ISM is to gain knowledge regarding biomedical engineering and expose myself to the work and field of engineering as a whole in order to prepare myself for my future career. With my mentor's insight and knowledge, I plan to create a successful and innovative final product to display at the end of the year presentation. In the future, I hope to provide my country and the world with new technologies and innovations to give people improved quality of life and longevity. Okay, so my goals for ISM are to create something that I can pitch to the world in general and make it a better place. It goes back to my quote right here, we can't help everyone, but everyone can help someone. I'm all about efficiency, and I want to make the world more efficient so people in other places that don't have the same efficiency as we have in, these first world countries like America, I want them to have that. I want them to have the ability to have that kind of life. So in ISM, I want to learn more about the biomedical engineering field and the engineering field. I want to try to figure out my life and my career and where I want to exactly take it, because I got a lot of ideas right now. I want to earn valuable business experience with my mentor and gain knowledge from her and be a sponge. And with my mentor's help, make an awesome final product. My goal in the long run is to help people and somehow make the world a better place, even if it's through really, really tiny, minuscule triumphs. Next I'm going to talk about my interviews, my 5 interviews. They were all in person and all around here in Dallas. Okay, my first interview was with Mr. Eric Selke, and he works for Spectral MD, and they're a startup company out of Dallas, and it was started by a guy with a PhD in engineering and a guy with who's a heart surgeon, and they do burn imaging, which is a really important field, not so much for domestic causes, but for a lot of military purposes. And they have a unit that detects the photon flow under the blood, like for burn tissue. And with the photon flow, after they can detect that with the unit, the surgeon can determine where to cut away the tissue that's either alive or strong. Meeting with Mr. Selke was really great. He had a really young outlook on the whole entire industry, and I'm really glad I got the opportunity to be with someone so fresh and new on the market. He had time in, I'll go back to him. He had time in sales, but he's in a quality engineering design job right now. So what he does is he makes sure everyone else on his team is doing the right thing and the product they're pushing out is the right one. Okay, my next interview was with Mr. Rob Snyder, who's one of Allie's friends. And he graduated with UT with a BBA, and he originally wanted to be in banking and accounting, but people change their minds a lot, probably like I'll change my mind. And he's ended up as a salesman at Karl Storz Endoscopy. Now, the thing with medical salesmen is they just have a business degree, so they're not exactly medical people, but they know how to sell their product, and that's their role. So what the points that he really stressed to me were that the medical device field is very reliant on salesmen, and 2 of my other interviewees, they said that too. They're very important as middlemen, and they have so many products to produce and sell that they have to know their stuff. So he said that Karl Storz has around 2,000 products, so he has to go out to surgeons, hospitals, and say, hey, here's my product. He has to pitch these 2,000 products to them, and after that he has to train them to use them, and he's usually in the operating room, which I thought was really cool during the surgeries. My third interview was with Miss Jessica Sampson, and she's my mentor. I couldn't be happier with her. She attended University of Idaho and earned a master's in mechanical engineering, and she is just a wealth of knowledge. She's young like Mr. Selke, so she has a lot to offer, and she's very insightful into how the industry is progressing. she really wanted me to know that I needed to know my way around design software and how to dimension designs and sketches to communicate with the other forms of the design team. She said that in any engineering situation, there's always going to be a team, and every member of the team needs to communicate and be on the same page all the time. And that's why whenever you make sketches or designs for a certain product, you have to make sure to dimension it and make sure that that design is clear to the other person, because you could be sitting in your cubicle drawing up this new part for something and then send it over to the guy in the machine shop, and he needs to know exactly how to make that without having to have any more communication with you. Okay, my fourth interview was with Mr. Clint Walker, and he was probably the smartest guy. He earned a master's in both biomedical and mechanical engineering, and he was a really great interview. And now he's in a hybrid role that fuses the engineering side and the design side with the sales production side. So what he's doing is he takes the ideas that the engineers take and he goes and shows them to the salesmen, and they optimize it for sale on the market. Key points that he said is be around people like you, communication is important, and never stop innovating. He really talked to me about how in college when he was at Duke, there are two kinds of people, and he was one of those kinds of people, and they were actually ended up in the mechanical engineering side of things. And so he really felt like he wanted to do mechanical engineering even after he got his master's in biomedical, just because he meshed with those people better, and he felt like he could be more productive in that field. My last interview was with Mr. Chuck Schreiber, who does the same thing as Mr. Snyder a couple slides ago, but he works for Ethicon, which is a division of Johnson & Johnson, the huge mega company, and they sell devices too. He told me more about the sales side of things, because that's really what he's done forever since he graduated from Texas Tech. And he stressed me like this really important view, like when a salesman goes to a hospital to sell products, he explained to me that they don't sell product by product. They sell everything in bulk, just like Costco. Because the medical industry is so expensive nowadays, it's a lot cheaper for a hospital to buy 4,000 products to last them a few years at one time than buy 100 or 200 a week to get them through that 2 or 3 month span. Okay, so my research has gone pretty deep for biomedical engineering, but it's not really gone past a certain point of like the mechanical engineering side. The bioengineering hasn't really interested me as much. But things that biomedical engineering can do is, as a marriage of biology and engineering, it can be cancer treatment, genetic engineering, prosthetics, and artificial organs, or anything that you would see in an operating room, the tools, the instruments, the LCD monitors, ultrasounds, anything that could be in the operating room. And there's Luke Skywalker's hand because I like it. One thing that I've really gone into for biomedical engineering are biomaterials and implementation. Kyle Alley and I sat in on a class on material sciences at UNT. And material sciences is huge because it's all about production. And they test these materials. There's all kinds of different polymers and metals, and they test them for strength, for weight. They test them to optimize them for manufacturing, whatever product they may be. In biomedical engineering, that's a huge, huge, huge factor, because you have polymers that are interacting with the body directly, or you have polymers that, like in my original work, need to be light, and you need to have a device that can be easily transportable, easily used, easily cleaned. So that's something that's really interested me, and I could see myself sitting in or being part of a lot of biomaterials classes in college. Biosensors, that goes back to the chemical engineering. I did a little research on that, but it ended up it wasn't for me. But it's when you put a certain like a marker cell into the body, and it picks up certain chemicals that may need to be changed or altered. Okay, how my view has changed. I talked about this a little bit earlier. Biomechanical and biomedical engineering is very, very niche, and as a biomedical engineer out of college, you don't have nearly as much like variance to like what you can do as a mechanical engineer. So if I graduated with a biomedical engineering degree, I could probably not do petroleum engineer. I probably could figure it out once I got the job, but the hard part is getting the job. If I went to petroleum engineering company and said, hey, I want a job here, they're going to say, okay, what's your degree in? And I'm going to say biomedical engineering. And they're like, well, we have 10 people behind you who have petroleum engineering jobs, and this is what they do. So I made up a little word here, nichiness. So biomed lacks because of its nichiness. So as of that, my mentor has actually talked me into switching to mechanical engineering, because even if I still want to stick with the biological side and the biomed side of things after college, I can still do that, because mechanical engineering transverses very, very easily into petroleum engineering, civil engineering, aerospace engineering. It's all there, the physics, the math. Okay, so now I'm going to talk about my original work, and I have stuff to pass out. I have like sketches and stuff. I have 4 copies. Hold on. What? Okay, yeah. So my mic. There's only 2 of the top ones, but yeah, just people can. I only have 5, so people can just pass them around. Oh, here's one more, too. Okay, so my original work. The first steps I took for it was 1, I identified a need, 2, I determined a goal of the project, and 3, I created something to fill the need I found regarding overseas and missionary surgery. So what I came up with that was a box, like a traveling salesman's box, that could open up, fold out, kind of like a tackle box or the traveling salesman's box. I know makeup and mascara are the same thing now, so I won't make that analogy. So it's for a surgeon to go overseas with everything they need, or for the most part everything they need, and make a surgery room out of nothing. So my initial design idea was what I just said. It's a box that folds out, kind of like this tackle box here. And it's going to be made out of ABS plastic, carbon fiber, and military-grade aluminum. And it's going to be optimized for low weight and high strength, so people can carry it overseas very easily, or overland, etc. It's going to be a system which folds up and out like a traveling salesman's trunk, and it also houses a cooled section for medicines and stuff, and an LCD monitor to hook up larger instruments to. I'll get into the larger instruments later. So my explanation for this is the need. The need for this product is there's poor conditions overseas and in South America for missionaries, and they don't really have operating rooms to work in when you're in a third world country. And this is going to make it easier for them to take everything they need for the most part and make an operating room out of nothing. The solution is my toolbox, my medical toolbox, that's what I'm calling it for now. And it holds essential tools and supplies found in a standard operating room, all packed into one container carryable by at the most 1 person. Now this is my original design. This is before my mentor intervened, so I'll walk you guys through that. So when I started designing with my mentor, after I got my mentor and I talked to her about this stuff, she had a lot of insight, and she told me things not to do and what not to do, and we brainstormed. So my new design process turned into this: establish a scope of product, identify must-haves, which are necessities, identify nice-to-haves, which are pretty much icing on the cake, and establish a bill of materials. In the engineering world, they call it a typical BOM. She told me not to say that in the airport because that's a bad idea. Incorporate all must-haves into design and as many nice-to-haves as possible. So basically, you make a scope, and the scope is almost like a mission statement for the product, and you have to fill the needs of that scope. But you don't want your scope to get too broad, because as it gets broader, bad things happen. Okay, Shayna, by the way, the 3 in the laminate, they're the same. So, yeah, okay. So establishing a scope. So what I just said, a scope gives the product that goal. And my scope that I developed for the medical toolbox was the purpose and scope of the medical toolbox design is to give a surgeon the tools to make an operating room out of nothing as easily as possible. The medical toolbox ideal will account for multiple tools, supplies, power tools, and situations a surgeon will need for space. However, with constraints given, not all of the bill of materials will be able to fit into the single box by itself. So what I did there is, because not everything can fit into this box that I dreamt up, that I designed, I had to make other solutions to it. So what I've developed is a system, almost like a building blocks, where you can order, from a production standpoint and a sales standpoint. If I was the company and a surgeon who was a missionary was my customer, they could get the main box, which comes with, I'll go through what it comes with, and then they can also get a separate power source, separate bigger tools like ultrasounds. Ultrasounds are huge, so are fluoroscopes. They're really big, they get in the way, and if I wanted to put an ultrasound in my medical toolbox, I'd take out room for a bunch of other stuff, like it'd just be a mess, and it'd be super heavy, and now like 3 people would have to carry it, and that completely voids my scope. So the scope really it doesn't narrow the path, but it keeps it from going off track, like crazy ideas that would never work. Okay, so my must-haves and necessities that that Ms. Sampson and I wrote down were weight management, budget, size, ease of use, transportability, power source, durability, safety precautions, standards of the operating room, and the number of docks per box. Now, number of docks per box means that how many doctors could this box supplement when it went overseas? Is it going to be enough for 2 doctors to be using at the same time? Is it going to be enough for 3 or just 1? And that's a good point for a production standpoint. I've really looked at it from there. How easy is it going to be to make, and how easy is it going to be to sell, and how do you optimize both of those? Okay, my nice to haves are convenience, compact design, variability. That goes back to the system having multiple other instruments outside the main instruments, like the bigger instruments, in their own little boxes, like 1 foot by like 6 inches by 6 inches, that another surgeon in the team could carry, or like a nurse, like, because these people go over in teams. It's not just one person. Another person could carry it very easily and then hook it up when they got to the location. Okay, more nice to haves would be bill of materials options, and the quantity to pack on a plane. How much can you get onto the plane as easily as possible, in one box, or as few boxes as possible. And then a one-stop shop. And the problems with that go back to the system I've developed. You can't fit everything you want in one box. That's impossible, and the scope would be completely violated if I did that. And it'd be way too heavy, it'd be way too cumbersome, and it's a lot easier to optimize stuff just in the single box, and then put the stuff that can't fit into the box in their other boxes, like power generators and the bigger tools. Okay, so my current final design, after my mentor's help, so it's the same medical toolbox that slides up and out, and it's composed of ABS plastic, military strength aluminum, carbon fiber, and the refined bill of materials is right here. So if you guys just want to look at this, I'm not going to read it all off. These are all pretty much necessities of the operating room, and stuff for like decontaminate. So I have like iodine, decontaminant wipes, because you have to keep it clean. One thing that my mentor and I went over was originally I wanted on one side of the box, like you guys will see in the sketches, wherever they are. I had a whole entire tray that slides out, just being decontaminant, that would close on itself and like decontaminate all inside there. Well, that's going to be way too heavy to make the machine to do that. It's going to be way too expensive, and it's just going to get in the way. So what I came up with is just pack like antiseptic wipes, and they can make their own cleaning station there, because it's just too much to fit into the scope. So that's my updated decontamination area. It just optimizes it for efficiency. Another thing that I really got into was the refrigerator section. The box itself really needs a refrigerator section, because these guys need to have medicine to take with them. And that medicine a lot of the times needs to keep cool, vaccines and stuff. So what I came up with is in the front side of the box, or as a separate option, it's all about options, a product line. It would be in the main box, it'd be like a fold down, and then the cooler would be like in the front of it, and then by itself it'd just be a little box itself. Very similar to a Yeti or a Hydro Flask. It keeps cool for up to 24 hours. So what you could do is you could plug it in here in the States, charge it for 24 hours beforehand, and it's going to keep that cool charge, and the waves are going to bounce back and forth while it's being transported overseas, and hopefully it will keep cool enough for the medicine to stay good until you can plug it back into power. That's a really high constraint, and it's still going to be worked on if I keep this for my final product, which I really want to. But it's a big constraint, and I need to work on it more. The separate box system goes back to the power sources and the individual larger machines. I think the power sources are here. So power sources, I have 3 options. I have gas, electricity, and solar power. Now those are on the sketches too. The electricity isn't going to be so much its own individual power source in a box. It's going to be more like hooked up already, like a transformer inside, just like any other machine would work. You don't need another attachment. That's just a waste of time. But the gas would be like a portable generator, like here in the picture, and it's going to be about that size, easily carryable by one person, a little heavy, but worth it. And it's going to be able to be portable, and then when they get there, because a lot of times in third world countries they have gas available. They might not have electricity, and they might not have clean water, but they're going to have gas because there's cars of some sort, or they've been touched by the outside world just a little bit, enough to have gas. Solar power, like on the sketches, I have a box that it's going to be the same size as the portable generator and the same kind of box made of ABS plastic to optimize weight and stuff. And it's going to fold up and out, very similar to the box, but then it's going to angle for the solar panels to fold out. The only problem that I've had with the solar panel idea is the weight and the price. I don't know how willing surgeons are going to be to pay, a lot of money for solar panels. So I think if I was doing this, my favorite option would be the gas, because the gas is a hands down winner. With the solar power, the only constraint that is a problem is the price. It's going to be a lot of money to put a few solar panels on and have that whole entire converter system in a box. Okay, this is more on the box system. It's so I'm going to have a whole product line, and what I also will have available is if a surgeon comes to me and says, hey, I have this certain instrument like an ultrasound that I want to have put in a box, I'll make a box for them, or my company will, etc. And I'll have that put into its own box and optimized to fit on, and everything will kind of click into shape. So just kind of like Legos, like I made the building blocks analogy, everything will kind of be click into shape. So when you get there, you can click it all together, and then it's just like one big spread, and you don't have stuff scattered, because this is all about efficiency, and the problems that surgeons face are everything scattered. You have all this machinery, all these instruments, all these devices being shipped overseas or down to South America, and it's easy to get kind of jumbled up. So I want to really limit that that problem. Okay, that's more in the fridge, the powered refrigerator that can keep cool. So looking into that. And then back to the decontamination. Many ways to do this, but I'm debating its efficiency, because when it reaches a certain point of intensity, how I want to make that, because at my mentor's factory or at OrthoFix, they have things that you put it in there. They have trays where they put their products in there, which are tools and bone screws. They put the trays in this huge machine, and it zaps it, and it's all decontaminated. You can't put that in a little box. So I think the best way for me to do that is with the wipes, and then they just make their own decontamination area. It will cut down on the money and size of the box itself. Okay, conclusion. I hope you guys understand my basic idea to help a surgeon efficiently create a working operating room out of a location with little or no resources. It's really all about efficiency and making it a lot easier for a surgeon to go overseas and make something out of nothing. It's really hard for them over there, and they have all kinds of stuff, and it's also hard to get through customs with it. And this would really limit the size and the constraints of when a surgeon goes through customs, I have this and this and this. Now it's all in one box. They can look at it once and it's all good. I just can't say typical bomb in the airport, because that'd be bad. So yeah, this is my original work. Thanks for listening. Hope you guys enjoyed it.